Hey, are you studying for the Terraform Authoring and Operations Professional Cert? Would you like to do some practice? Let's try module refactoring. What's up, everybody? This is Ned Bellavance, nedinthecloud.com, and today we're going to cover a scenario that will help you study for the Terraform Authoring and Operations Professional Exam, which I'll just call the TAO Pro because I'm lazy. If you're not familiar with the TAO Pro exam, you can check out my video on the topic and HashiCorp's website for more details about it. The too long, didn't watch, didn't read is that TAO Pro is a practical, lab-based exam that includes several scenarios for you to work through in a live environment. Now, currently the exam is AWS only, with Azure and GCP support coming later. So the examples in this scenario we'll be going through are only AWS. For now. I'll eventually have Azure and GCP ones once those exist. You can look through the full list of objectives here, but I don't think making a video covering each sub-objective is the best way to learn things, especially given the scenario-based approach of the exam. So instead, I'm creating videos that focus on a scenario that covers many of the sub-objectives at once, which brings me to today's scenario. In today's scenario, we're going to be dealing with how to refactor your root module to use child modules while not disrupting existing infrastructure. Here's the setup. Imagine you've recently inherited a configuration from your team. The root module deploys a VPC, an EC2 instance, an S3 bucket, and some other related resources. The configuration is in active use and it's managing real resources in AWS. Your team would like you to refactor the code to use modules for the EC2 instance and the S3 bucket. This change should not disrupt the infrastructure currently being managed by Terraform. They would like you to write a custom module for the EC2 instance that might be adopted by other people in the organization and use the S3 bucket module from the public registry for the S3 storage. Let's take a look at the root module first and then review the requirements from your team. Okay, over in Visual Studio Code, I have the configuration open here to the main.tf file. In the main.tf, let's go over what's actually in the configuration. We've got our AWS provider block using a hard-coded region of US West 2. We have a VPC being created and also a subnet in that VPC. We have an internet gateway and a route table that is using that internet gateway for the default route, and then a route table association between the route table and the subnet. It's all pretty normal stuff for setting up some networking. That's not the part we're trying to replace. Scrolling down a little bit further, we have our EC2 instance configuration information. The first thing is using a data source to query for the latest version of Amazon Linux 2 for the region that we're currently working in, and you can do that by querying the SSM parameter store. Then we have our actual AWS instance resource that we're creating. We're using the value from that previous data source that has the AMI ID in it. We're creating a T2 micro, we're using the subnet that's being created, and we're going to use a security group that we'll look at in a second. We are passing some user data that's coming from a file called startup.tpl, and when that user data changes, we're going to replace this instance. Finally, we have a tag of name equal to web server. Below the instance, we have an AWS security group that is meant to allow HTTP traffic on port 80 to our EC2 instance. Below that, we have our storage section where we're creating the S3 bucket, and that's made up of a few separate resources. First of all, we're creating a random string for our bucket name so that it can be globally unique. Then we're creating a bucket named myBucket with that unique string, and setting force destroy to true, which will allow Terraform to destroy the bucket even if there's information in the bucket. Next, we're setting the ownership controls with the rule of object ownership to bucket owner preferred. This is required if we want to set an ACL for our S3 bucket using the newest version of the AWS provider. And then finally, we have the AWS S3 bucket ACL that is set to private. Now, this depends on that ownership setting being applied, so we add an explicit depends on to make sure that that ownership control is applied before it tries to apply the ACL. Otherwise, we might get an error during apply. Finally, we have two outputs defined, a public DNS that's made up of the public DNS of our EC2 instance, but we add on the http:// so it's easier to just click on the link from the output. And then lastly, we have the S3 bucket name being passed as an output as well. And this is based off of the S3 bucket resource and the bucket attribute of that resource. That's everything that's in the configuration. Now let's talk about the requirements from your team. First, let's talk about the requirements for the EC2 module. The team would like a local module created for the EC2 instance at the folder path modules/instance, and that is relative to the root module. Inside the module, it should contain two resources, the AWS instance itself and an AWS security group. That's a minimum. You could choose to include additional resources. You will need to create input variables to pass information from the root module to the new child module. The following information should be configurable for the EC2 instance: the AWS AMI, the subnet ID, the name of the instance type, the user data contents, and the port to allow for the security group, because it might not always be port 80. Your module also needs to pass back the public DNS of the instance as an output. Remember, the modifications should not destroy or modify the existing EC2 instance or security group. Before we take a look at my solution for the scenario, this would be a great opportunity for you to try to solve this scenario yourself. If you go to my repository for Terraform Tuesdays, there is a TAO Pro 1 folder that has this challenge in it. You do have to deploy the infrastructure first before you try to do the refactoring, but if you would like to try it yourself, go ahead and pause the video, try it now, and then when we come back, you can look at my solution for the EC2 module. Okay, welcome back. Let's go over my solution for the EC2 module. Over in VS Code, I have a module refactor solution that has the actual solution for both the S3 module and the EC2 module. Let's take a look at the contents of the EC2 module first, and we're going to do that by looking at the input variables first. Remember, the input variables are defined by the information we need to ask for, and that was part of the requirements. So looking at the variables here, they are in alphabetical order, so I'll cover them in that order, which that is best practices to put your variables in alphabetical order in your module. So first we have the AMID. We do want to ask for that string directly. Now we could do it a different way. We could assume that the consumer of the module always wants to use Amazon Linux too. And then we could use the data source that was in the original configuration and put that inside of our module. If we go back and look at the original configuration, we're using a data source to get that AMI ID by using the SSM parameter store data source. We could move this data source into our module, but I'd recommend against doing that. And the reason for that is because we don't know what the consumer of the module is expecting. And the simplest thing that we can accept is a string for the AMI, because the argument for the instance resource is looking for a string. However, the person consuming the module wants to get that string, whether they're pulling it from a data source or passing it as an input variable, that's up to them. We want to leave that implementation detail up to the consumer of the module and not take on that dependency ourselves. This is what's known as dependency inversion, and we'll see it again later in our module. Next, we have the ingress port, and this was something that was specified in the requirements. We have to accept a setting for the ingress port. Next up, we have some instance-related information, the name, the instance type, and the subnet ID that's being used by the instance. And then next, we have another example of dependency inversion. For the user data for our instance, we are accepting a string that will contain that user data that we want to pass that's going to be a startup script of some kind. Now, if we take a look at what's in the original main.tf for our EC2 instance, we were getting the contents of the startup.tpl file from a file path and passing that to the user data. We could take that same approach in our input variable. Our input variable could, in theory, take a file path and then use the file function to grab that. But what if our consumer of the module doesn't want to get the string for the user data from a file? What if they want to use template file? What if they want to get it from a data source instead? There's a number of different ways they could potentially generate that user data that we don't know about. So rather than making a decision for them, instead, we're going to leave it up to them and just accept a string as the input for our module. Again, it's that dependency inversion that we're going for here and pushing the decision back on the consumer rather than making it for them. The last thing is the VPC ID, which is required for configuring the security group. That's all of our input variables. Let's take a look at the main.tf for this module. In the main.tf, we have our two resources. The first is the security group, and it's almost the same as it was when it was in the root module. The major differences are that the VPC ID is now using an input variable as opposed to a direct object reference, and the ingress port is now configurable using our ingress port input variable. Scrolling down to the EC2 instance, we've replaced basically all of the hard-coded values with input variables, and that includes the AMI, the instance type, the subnet ID, etc. I did leave the user data replace on change equal to true. We could make that configurable if we wanted to, but that wasn't a requirement, and I'm deciding to make a decision for the consumer of this module. It could be a future team discussion whether we want to revert that to using an input variable that has a default value of true. That's everything that's in the main.tf. The last thing to look at is the output. So under outputs, the only output that is defined is the one that we need, which is the public DNS of our EC2 instance. And I haven't included the http:// on the front, because again, I want that to be a decision by the person consuming the module. I don't want to assume that what they really want from the public DNS is a clickable link. So I'm just giving them the raw information and then letting them make the decision about it. Now that we know what's in our EC2 module, let's take a look at how the module block is implemented in the root module of our configuration. Back in VS Code, I have a new module block here called web instance, and the source is set to the relative path of module/instance where our new module resides. The rest of it is just the input arguments that we configured for our module. The AMI ID is taking the value from our data source, just like our EC2 instance was before. We're setting the ingress port to 80, the instance type to T2 micro, the name to web server. We're using the same subnet, the same VPC ID, and once again, we're getting our user data from that file and passing that string into the module. So it's pretty straightforward how we're making use of this module. That's going to do it for the EC2 module. Now let's talk about the S3 module. For the S3 module, the team has given us the following requirements. They want us to use a module from the public registry to replace the S3 bucket resources in the defined configuration. The module that we're using is found here on the registry, and they want us to use the exact version 4.2.2 because that has been tested by the rest of the team, and they feel good about that version. So we want to make sure that we specify that exact version when we create our module block. The current configuration should leverage the module to replace the following resources: the AWS S3 bucket, the S3 bucket ownership controls, and the S3 bucket ACL. We'll use the outputs of this module to update the bucket name output for our root module. Now, it is okay to replace or update the bucket ownership controls and the bucket ACL resources as long as the S3 bucket itself is not destroyed and the output for the bucket name does not change. So as long as what's in the bucket and the bucket itself is not disrupted, it's okay to change some stuff around it. The team has given us some wiggle room on that. Okay, let's take a look at our solution, but before we do that, you may want to pause the video and try to solve this yourself first. Go ahead and do that now if you want to, And when we come back, we'll take a look at my solution. Unlike the EC2 module, which we were writing ourselves, so we had to go in depth with some decisions about input variables and stuff like that, now we're using a pre-existing module. So what we're really needing to do is update our main.tf of the root module to leverage that module. Back in our solution, in the main.tf for the root module of our refactored configuration, I've added a module block called webbucket. And we're sourcing the module from the public registry that we were asked to use, and specifically setting version 4.2.2. We're not using a range, we're using the specific version of 4.2.2, which is what we were asked to do. Below that, we are setting some arguments. Now, to figure out which arguments to use, we have to go back to our original resources. Remember, we were creating an S3 bucket, applying ownership controls, and a bucket ACL. The arguments we use for the module are going to correspond to different components because the module deploys all of these things. Now, in the actual lab environment, you'll have access to look at the Terraform public registry, but you won't have access to look at the code underlying the modules if they ask you to use one. So we're going to try to do this by not looking at the underlying module itself and only what's on the Terraform public registry to figure out what we need to do. For starters, we have to create the bucket and set force destroy to true. So we have to determine from the module which arguments are used to set the bucket name and force destroy to true. Over in the module, I'll scroll down to inputs and we'll try to figure out that information. We'll start by just trying to find the name of the bucket, and it would appear that the argument for that is just called bucket. Easy enough. Now, what about the force destroy? I'll look for anything starting with force. And sure enough, there is an argument force destroy, which takes a Boolean. So now I know I can use both of those arguments in my module block. Going back to the code and looking at the refactored solution in my module block, sure enough, the argument bucket is taking the bucket name and force destroy is there and set to true. I went through the same process for the other inputs that are included in the module and found the ones that corresponded to the resources that I was configuring in the original root module. And from that, I set control object ownership to true, set the object ownership to bucket owner preferred, which is what we had before, and set the ACL to private. So this should line up to the way we had our resources configured in the original root module. That's going to do it for the S3 module. Now let's see how we can implement these modules without disrupting the actual infrastructure that's being managed by Terraform. And we're going to do that using moved blocks. Back in our configuration, if we scroll down below the module for the web instance, I have two moved blocks here, one for each resource that has been relocated to a module. If you're not familiar with move blocks, I did a whole video on them, but the long and short of it is, it tells Terraform that a resource that is being managed and has an entry in state data is moving to a new address in state data. And so that will prevent Terraform from destroying the resource at the old address and recreating it at the new address. You're telling Terraform, no, it's the same resource, it's just changed addresses in my configuration, so make the state file reflect that change. It should be a non-disruptive change to the actual infrastructure. In our configuration, we have two moved blocks here. The moved block takes two arguments, a from and a to. A from is the original address of the resource that is being moved, and the to is the new address of that resource. Let's take a look at the instance first. If we take a look at the original configuration for our instance, it was at the address awsinstance.web. And that's what I've put into the from argument. Where is it moving to? It's moving to a module, and the address of the resource will be module.the name label of the module, which is web instance, .the resource, which is AWS instance.web. I didn't change the name label when I moved the resource block into the module, which makes it a little bit easier. Then we have the same thing for the security group. The security group was at AWS security group.allow HTTP, and now it's at module.webinstance.aws security group.allow HTTP. Those are the moved blocks for our two resources that are in the EC2 module. Now let's take a look at the moved block for our S3 bucket. For the S3 bucket, I only have a single moved block, and that's because the team told us that they didn't care if the ownership control or the ACL resource was replaced, as long as the S3 bucket itself wasn't disrupted. So all we really care about is moving that S3 bucket. The from is AWS S3 bucket.bucket, which corresponds to what was in the original configuration. It's moving into the module.webbucket, but what is the rest of that path? That's something that we can only determine by looking at the module itself. So what I'm going to do is jump back over to the module and scroll up to the top and take a look at the resources that are deployed by this module. One of them should be the bucket itself. And sure enough, the second entry is AWS S3 bucket.this. Now I know what the name of the resource is inside of the module. Now, if we go back to the code, you'll see that I have the S3 bucket.this on here, but I've also added on an element for this. And that's because I know that it uses the count meta argument, but let's see what happens if I didn't include that, if I was just going by what's in the module. We'll see that in a moment. The last thing I want to cover is the two outputs down at the bottom. For our public DNS, we had to update this output to make use of the module output from our new EC2 instance, which we know we named that output public DNS. So the updated expression is module.webinstance.publicDNS. That should be the exact same output that it was before. And then for the bucket name, I had to go back to the module code to find out what the output was defined that gives you the bucket name. If we go back to the top of the module and go to outputs, we can scroll through the outputs here and see that the S3 bucket ID corresponds to the name of the bucket. So that is what I will replace the old value with so that we can return back the bucket name in the form that it was before. All right, those are all the code changes. Now it's time to test things out. Did we get everything right? Who knows? This is where the rubber meets the road. So let's jump back and actually start running some Terraform commands to at least validate that our module is correct, make sure it's formatted properly, and then test out with a Terraform plan that we're not going to impact our existing resources. Okay, back in the configuration, what I did was I actually copied the state file from the module refactor directory into the module refactor solution directory. So it's using the same state and managing the same resources so I can test out my changes. In a real world scenario, you would be making these changes directly in the root module and controlling things through source control. But to keep a copy of both, I've chosen to do it this way. Now let's open up the terminal. And I'll start by going into the correct directory, which is probably helpful. And now that I'm in the correct directory, the first thing I need to do is run Terraform init. I would need to do this even if I was in the original directory because we've added modules. And the Terraform initialization process is what downloads those modules or creates entries for local modules in the modules.json file. Now that that initialization is complete, let's make sure that my state has been loaded properly. I'll do a Terraform state list to list out the resources that it finds in state data, and sure enough, these are the resources that were from the original deployment. Excellent, good to know. Since we created our own module, I want to make sure that the formatting in that module meets standards. So I'm going to run Terraform FMT, and I'm going to add a flag here called recursive. The recursive flag goes into all subdirectories and properly formats those files. Now, I already ran this once, so everything was properly formatted, but if it hadn't been, it would have formatted it properly now. The next thing I want to run is Terraform validate. And Terraform validate will just do a syntactic and logical check of the layout of my configuration. If it finds any errors, this is my opportunity to fix those errors before I try to run a Terraform plan. Looks like my configuration is valid, go me. So next up, let's run a Terraform plan to see what it's going to do if we actually run and apply. Ideally, we'll see no changes to existing resources. Okay, the plan has completed, and in the summary, I see 4 to add and 3 to destroy, and that is too many things to destroy. I don't love that. So let's take a look at what it's actually planning to do by scrolling up a little bit and seeing what resources are going to be destroyed. Scrolling up to the top, the bucket ACL is going to be destroyed. That's okay. We said that was okay, so I'm not worried about that. Scrolling down to the bucket ownership, that's also going to be destroyed. And again, that's okay if the module is going to recreate the same one. But the S3 bucket is also going to be destroyed, and we don't want that. That's a big red flag. Why is it being destroyed? And it tells us in a nice little comment here, because the resource uses count or for each. Now let's take a look at the resources that are being created. Scrolling past the bucket, it is creating a brand new S3 bucket, and the address is slightly different. It has an index on the end, that bracket 0. Aha! This is why our moved block didn't work the way we expected it to. It's because the module uses a count to make the bucket creation optional. And so if it does create the bucket, it's going to be at this address at element 0 because of the count met argument. So what we need to do is go back into our code and update the moved block to include that 0 element at the end of the address. Now our moved block should work properly. Let's review the rest of the plan and make sure everything else looks good before we run a new plan. Below the bucket, it's creating a new ACL that's using private, which is what we want. It's creating a new ownership controls that is using bucket owner preferred, again, what we want. And it's creating this new public access block, which sounds pretty good to me. And let's assume I ran it past the team and it sounds good to them. So everything else looks good. We just need to tidy up the moved block to make sure that it works like we would expect. It also lets us know that our AWS instance.web is moving successfully, as is our security group with no changes to either. Since we made those changes, let's run a fresh plan to see what the results look like now. Okay, our plan has completed, and this looks a little better. Now I'm down to 3 to add and 2 to destroy. And if we look at the contents here, the 2 things that are being destroyed are, again, that ACL and the ownership controls. That's fine. It's recreating both of those. It's also successfully moving our S3 bucket object to the new address. And that's what I was looking for. I'm feeling pretty confident about this. So now I'm going to run a Terraform apply. And once it finishes generating a new plan, I will approve that plan, assuming it's the same. And it will make those changes to our resources without disrupting the existing EC2 instance, S3 bucket, and the security group. And if we go to the link that it gives us, our EC2 instance is still running, and we get some tacos. Okay, so what did we do in this scenario? What did we accomplish? We took an existing root module that was managing real resources in AWS, and we wrote our own module for the EC2 instance and used the S3 module from the public registry to replace some of the resources in the root module. And then we made use of the moved block to ensure that the existing resources in AWS weren't disrupted by our changes. Now, we could have used the Terraform state mv command to do the same thing as the moved blocks. However, that's not the recommended approach ever since the moved block was available. It's much safer to do everything through the moved block declaratively because it follows the Terraform plan and apply cycle, whereas the state mv command makes direct changes to state, and we don't like that. Okay, so that is the entire scenario. I hope you took a moment to yourself and actually tried to walk through it, or at least you found this informative. I'm going to put up a LinkedIn poll for the next episode in this series, and we'll cover another scenario. So keep an eye out for that, and please respond with what you want me to cover next. I have a few different scenarios in mind. If you have a scenario that you want to suggest that's not in the poll, just leave it in the comments. I also want to recommend the TAO Pro certification guide that Matthias Fjellstrom made. If you haven't watched the video with him, I'd recommend it. And also go out and buy that TAO Pro cert guide. It's really good. And let me know if you take the TAO Pro exam and pass. I would love to hear feedback from you about the exam, your experience, and what materials you found helpful. That is going to do it for today. Thank you so much for sticking with me all the way to the end. Like, subscribe, do all those things. Till next time, keep calm, Terraform on.